So, hello everybody, we are back again. So, in this class, we will be starting the plasma application, and in that, we have already discussed the different areas what we are planning to target to discuss in this section of thermal and cold plasma applications. So, the first one that we will like to address is the thermal plasma technology as an environment friendly route for waste management. And I have used the term waste to wealth. This is true by all means that waste processing sector is now one of the most profiting sectors in the waste management area. So that waste management using thermal plasma uh, is a very useful technique, and why it is so, and what benefits you can get out of that, and why it is called environment friendly, and what wealth you can generate out of it, that we will discuss in this lecture. So we start. In this slide, what you are seeing that this is one news article from 2019. As I have just copied and pasted it over there, I have no contribution in this slide generation. So what I have copied is that the newspaper is saying waste to energy plants that use solid waste as feedstock pose threat to environment. Necessity of high temperature they are highlighting as WTE plant. WTE means waste to energy plant in India. Plants in India burn mixed waste. The presence of chlorinated hydrocarbons like PVC results in the release of dioxin and furan when the waste is burnt at less than 850 degrees centigrade. So, appropriate filtering mechanism need to be installed to control such dangerous emission. So, this is what the newspaper is saying. And why they require high temperature? They even know that this is required because if you burn at temperature less than 850 degrees centigrade, then some very carcinogenic components called dioxin and furans they will be generated, and they are not good for our health, and they are really dangerous. So the emission remains a major issue with the residents. They are saying the plant was slapped a fine of so many lakhs so by National Green Tribunal. So what the message that we want to get from is that normal conventional waste to energy plant, this concept is not new, but the waste management technique that has been in use, that had been in use is not a good one. That is not good to the good for the environment and not for the citizens who are living around that plant. So why that is? They are burning at lower temperature. They are saying that less than 850 degrees centigrade, and that is the temperature usually you achieve when you burn normal waste in open. Okay. Suppose you have a dump of papers or leaves of plants and some weeds, and you want to burn them, then the temperature that will reach is somewhere around this temperature and not more than that. And when you burn material at such low temperature, then certain compounds are generated which are very carcinogenic in nature. So what we require is a high temperature, but what will provide you a high temperature easily more than 1000 degrees centigrade? So resistive heating is one of such method that you can use, but that is not very effective because it is there where your coil will be there, the resistive coil. It will not flow anywhere. So, and also it cannot give you temperature more than say 2000 degree or 3000 degree centigrade because the material cannot withstand such high temperature. So, the other alternative is the plasma. As we have learned through our course that thermal plasma can give temperature in excess of 10,000 degree Kelvin, not 850, not 1000, it is 10,000 degree Kelvin. So, more than that it can give easily and effortlessly, which no other mechanism can generate. So, our aim is to uh, treat all those waste which are put over the dumping ground and convert that into some useful and um, value added substance and make the area clean to a zone which is cleaner and greener to us. Okay. So, obviously, this is a dream that everybody would like to have the kind of transformation we are talking about, but what is the magical tool that will give you that thing? So, this is a thermal plasma device that has been developed, or this kind of devices are available. Some of the global companies are already making this, but the thing is that generating a large volume plasma over a wider zone and having a temperature in excess of 10,000 or say 8,000 degree Kelvin. So, that is a challenge rather. So, nowadays this kind of devices are available, and even in India they are available now, and these devices can be used uh, for processing the kind of waste we are talking about, and the temperature at the core of the plasma jet that can go really in excess of 10,000 degree Kelvin. And this is when the device is operating, this is the current and this is the voltage what you are seeing over there. So, if you multiply this two, this is consuming a power around 30 kilowatt or around that. Now, when you are consuming this much of power, this is not a very high consumption when you are talking in terms of say 1 gigawatt or kind of plasma what people are thinking previously. Now, it is such devices are available with much lower power rating. So, basically what it is doing, it is consuming lower power, but providing you a longer plasma jet, larger volume plasma jet at a temperature which is beyond say 8,000 degree Kelvin or 10,000 degree Kelvin, and which can be used to mitigate the waste in a very environment friendly and that economic way. So, you will be producing some material which is very useful to the society and which can be used for as a fuel, as we will see. Now, I come to the thing where from the plasma inherits is its ability to mitigate the waste in such a such a intense manner, such an intense manner, how it can mitigate the waste, where from it gets its potential. So, you have seen already from the equation that we have studied in our theory classes in fluid model that these are the mechanism that it inherits. So, this is conductive, this is diffusive, this is ohmic heating, this is radiative, and this is chemical reactions. Now, all these are together applicable when you are going for this thermal plasma treatment of waste. So, this extremely high gradient in the arc kind of device, the kind of plasma jet that you have just seen, that allows intense conductive and diffusive heat transfer. Okay, because of the very high gradient, this K grad is there. K is the thermal conductivity, and grad is the gradient in temperature. And this J dot grad term is there. This is especially for the plasma, and this is the ohmic heating, which the resistance that conductivity comes there actually. So, this sigma square term presents the ohmic heating term and this radiative loss because of the very high temperature, and plasma is having some chemical species which can react, and many of the reactions are highly exothermic. So, those reactions will produce energy which may be more than the electrical energy that you are pumping in. So, that is really true. So, availability of ionic and atomic species, they allow the reaction to occur in a more vigorous way compared to the normal reaction rate. Okay, so when you are using say atoms, the reaction will be faster than when you are using molecules, and when you are using ion it will be further faster, and when you are using in plasma form with many kind of species together along with the electrons which are essentially a component of the plasma, then the reactions become very vigorous and it can result in a processing of the material in a very efficient way. Now, what are the different areas that the plasma based waste management can address? So, one of the things is that it can produce a cleaner and greener environment, as I have already told you. Now, you know, it is producing enormous amount of heat, and when you are actually mitigating the waste in proper way using thermal plasma, then the amount of energy that is generated from the waste itself through chemical reaction sometimes constitutes the 95% of the energy that is generated inside the system, and only 5% is belonging to the electrical energy. So, a tremendous amount of heat is generated from the waste, and that heat can be used to produce steam, and you know that when there is steam you can rotate the turbine and you can generate electricity. So, one way is to generate electricity using this plasma incineration or plasma gasification process. The steam that you have generated, it has rotated turbine and generated electricity, and if you don't want to do that, that steam itself is an agent for many chemical reactions in chemical industries. So, if you are able to install such a waste management plant near the chemical industry zone, then you can supply only the steam to the industries, and that can contribute in a very significant way to the in economical terms. Then what you can do, you can produce from the waste, whatever carbonaceous waste you are using, you can produce syngas. What is syngas? That consists of mainly carbon monoxide and hydrogen. Now, this syngas C1H2, if you are able to purify from the carbon particulates properly, then that acts exactly as a CNG gas, so which can run the engines. So, you can produce syngas and pack it, make a package along with normal CNG gas, and you can deliver that for running the engines. As a fuel you can supply that. Then the next generation fuel is what? That is hydrogen. Hydrogen we call as the next generation fuel. Now, from the syngas what we are getting? We are getting CO and H2. Now, if you are able to separate out hydrogen from this combination of gas, then what you are producing? You are producing pure hydrogen, and that can be used to as a next generation fuel, and you can already the cars are available which can run with hydrogen. And now I will tell you another possibility. If you are not interested or you are not capable of generating the CO plus H2 as a syngas, or you are not able you do not want to separate out hydrogen from that, then what you can do, there are now standard catalytic converters are available which can convert CO and H2 to methanol. And methanol is one substance which is being imported from outside by India in, you know, in uh, in, uh, in a huge quantity, right? Like in terms of CR, that is the crore, you can see the graph that has been shown over here. In 2013-14, the amount that has been imported is 4,000 crore, around that actually, or it may be around 3,500 crore. So, and in 2015-16 it is coming around say 2,500 crore of rupees of methanol that has been imported. So, this is an information from the source, Ministry of Fertilizers and Petrochemicals. So, since India is importing such huge quantity of methanol from outside, and if you are able to process just the waste and able to synthesize this methanol out of the waste, then that is nothing better than that. So, so far what we have seen that we can use the waste to produce green environment, we can generate electricity, we can produce steam for chemical industries, we can produce syngas like CO plus H2, and we can run engine using that just like CNG gas, or we can produce next generation fuel like hydrogen out of that, or we can produce methanol which is being imported by India, by our country in huge quantity. So, now you see, if we are able to process this waste using plasma technology, we are able to make so many useful things. So, now the term waste to wealth is very much clear to you. Now, I am coming to a third useful um, area where plasma can be used to treat the waste is the last one. This is urban mining. You know the mines, what we get from there, for example, suppose copper mine, you will, uh, you will collect tons of ores and you will process that, and compared to the original ore, the purified material will be very less, because most of the collected material from the ore will be eliminated in the purification process, and ultimately the purified material will be a tiny fraction of the original material that you had collected. So, that is the kind of thing that you get from the mines, from actual mines. Now, this is called as urban mine. Urban mine is what? Nowadays almost every household using large number of electronic gadgets. Now, all these electronic gadgets are having their PCBs. Now, PCBs are having components within that, and they are having interlayers of coppers. Then they may contain the leads which are having precious material like gold, silver, and it may unavoidably include your aluminium, iron in the course of the transformers, tiny transformers which are being used. So, all these things will be there. Now, what plasma does, that those components, the electronic components which are there attached to the circuit board, the circuit board is basically contains layers of this epoxy resins, and within that epoxy there are interlayers of these coppers. Now, the board, that circuit board, is so hard and so so rigidly fixed with the components that using any other method, extracting the copper which is there inside the boards, or extracting the material which is there is difficult. But when you are applying plasma, they can be done so easily that I will just show in some of the slides that I will be presenting. Now, typical plasma gasifier for this municipal waste management, what was dumped there in the initial slides that I have shown in the dumping ground. So those material can be processed using this typical plasma gasifier technique. So what are the components there? So there is a waste feeder using this mechanism. So it may be a conveyor belt, it may be a skip waste kind of thing, where there is a tub, you can fill it and you can pour in the chamber, where there is a mechanism to feed into inside the chamber. Okay. Now, what is there? This is containing basically, four major components. One is this primary chamber. I will explain it in a more detail. Then there is a secondary chamber which is used for burning the residual gases. Then there is a venturi scrubber which is a very useful component. I will tell you why. And then this is a packed bed column where you are scrubbing the gas using normal water, and then the final purified gas, then it is clean gas, is fed into an ID fan which is blowing out the gas into a stack. Now I come to the plasma business. So you see at the bottom of this chamber, so this is this primary chamber, and at the bottom the plasma torches are fitted in there. So they are discharging the kind of plasma that I have already shown in the video. So this plasma is discharging inside, and as I told you from the beginning that the temperature zone of the high temperature zone in the plasma jet is very narrow. So that narrow zone cannot provide, although the temperature may be high, more than 10,000 degree Kelvin, but that is limited to a very thin zone, maybe say a few centimeters thick zone where your very high temperature is there. But there are two facts: neither you want so high temperature, we want just more than 1000 degrees centigrade, we don't need more than 10,000 degrees centigrade. The other thing is that we need the temperature more than 1000 over a wider range, so that we can process larger amount of waste. So what we are seeing here, this is a coke bed which is used as a diffuser of the thermal energy. So there are big coke chunks, within that there are gaps, and the plasma is discharging into the coke bed, and the temperature which was 1000 degree at the exit of the torch, maybe 10,000 degree or more at the exit of the torch, that is getting redistributed in the coke bed zone, and overall temperature is coming down, but the temperature is getting distributed over a very wide zone. But at every point, any point within that zone, the temperature is more than 1000 degree. And at the discharge location of the torch, the temperature is more than 10,000. But on the bed, at the core, usually the temperature is more than say 2000 degrees centigrade. But overall, at any point within the coke bed zone, the temperature is more than 1000, and that is what we require to treat the waste. As you have seen that the temperature should be more than 1000, so that you can reliably say that whatever gas that you are producing, all the carcinogenic components are broken into their elementary components. Just for example, suppose you have carbon and nitrogen. Carbon is everywhere, where you are sitting there is carbon, your shirt is containing carbon, and nitrogen, there are plenty in the atmosphere. Okay, more than 70% of the atmosphere is nitrogen. Both are benign. Carbon is benign, nitrogen is benign. But the moment they are joined together, they form CN, the cyanide. So cyanide is one of the very dangerous compound that you know. Okay. So the reverse way you think, you have cyanide and you are applying a very high temperature plasma jet which is breaking the CN bond. So C is now benign, N is now benign. So that is the principle of carcinogenic waste management using thermal plasma. This is because thermal plasma is having high temperature, getting the ability to break the bonds, and making the things benign. Whatever hazardous material you do have, you put that into plasma, thermal plasma, and that will break all the bonds and make them benign by breaking that into their elementary, breaking into their elements actually. So this is the your primary chamber. So this is the hopper in which you put the waste, and there is a feeding mechanism so that you have you can always isolate the chamber from the outside, and still you can feed the waste. So the waste is coming through this and getting poured into the core of the plasma. Now this chamber, primary chamber, is having there three zones. One is your coke bed zone, where you have diffused the plasma torch heat and made a very wide bed which is having temperature at any point more than 1000 degree Kelvin. And then there is a gasification zone where the waste that you are putting, they are getting gasified. Now at this point I should tell you what are the different kinds of burning mechanism. There are three kinds. One is called open burning, like your incineration, that is one, where you are giving plenty of oxygen, more than what is required for the stoichiometry reaction, so that it carbon forms CO2, okay, the kind of thing. Now there is a process called gasification, where you are not giving sufficient amount of oxygen. So what are the stoichiometry requirement? You are giving less than that. So in that case, what is happening? Instead of forming CO2, you are forming CO, because there is not sufficient oxygen. And the third case, where you are burning the waste in absence of oxygen, so complete absence of oxygen. There what you are getting? You are breaking just the bond. CH bond is broken, so C is there, H is there. If there is O, that oxygen will be coming out, but not any external waste. Now suppose you have only CH bond, then C is broken, H is broken. So H combines and forms H2, H2 is gas, but C stays at the bottom. So what you will get at the end of incineration, lots of carbons deposited at the bottom and rest have gone out. So there will be a weight reduction, but carbon will not get evaporated. And what is there in gasification? You are giving limited amount of oxygen. So C is not being able to form CO2, but it is forming CO, and CO is a gas. So you are actually not getting anything residue on the at the bottom, but you are getting CO and H2, a combination which can serve as a syngas. So that syngas can be used, as I told you, to run engines, or they are produce methanol, or you can separate out hydrogen, whatever way you want. So they are very useful material you are getting at the end. Now you know that if you are introducing some metal as well, so the temperature being in this zone, actually in the gasification, it is very high, and that metal will be melt and will be coming out as a slag at the output port. Okay, so this slag can be collected, this metal slag, and as you know, this is a very valuable material. So what you are getting in this waste processing system is that you are having a primary chamber where from you are producing CO and H2, and if you don't want to use this CO and H2 for any processing, you can burn it out here, you can generate energy, and that energy can be tapped to produce steam, rotate turbine, and all this. And if you want to collect the syngas CO plus H2, then you make such mechanism, you purify it, and then you use as a fuel gas. And the other thing, that dioxin and furan, the most carcinogenic component what we are talking about, they are having this kind of structures. And what plasma is doing, if you are raising the temperature more than 1000, they are breaking all the bonds. And what are there actually? They are carbon and benzene like structure. So oxygen, carbon, chlorine, they are all getting separated and coming out as gas. So this most toxic your isomers are shown here, dioxin and furan. There are many isomers of that. The most toxic ones are this, and you can break the bond. They are toxic to the limit that even in the nanogram level they are very carcinogenic. So by breaking the bonds, you are able to make them benign. So that is how the thermal plasma technology makes this possible to treat any hazardous waste, and to avoid any recombination of the produced material like dioxin you have broken, and if they are cooled down they again form back the dioxin. So to prevent that, what you do, you break the bond, and then the very high temperature gas is cooled down using this Venturi scrubber. So this is an instrument which can cool down from say more than 1000 degrees centigrade to less than 100 degrees centigrade extremely quickly in fraction of a second. So the time to recombine gets reduced tremendously. So they cannot form the dioxin furan back in a very significant manner. So that is why this Venturi scrubber is a very useful element in this whole processing system. Then the gas what is coming out again scrubbed out in scrubber bed using water, and there is an alkaline tank. Actually this scrubbing solution is alkaline in the Venturi scrubber, which scrubs out the acidic gases because this is an alkaline solution. So what at the end you are getting a very clean gas at lower temperature, say around 40 degrees or centigrade or so, which is containing no harmful components. So that can be released through the stack to the outside environment. So I stop here, and in this you have learned how thermal plasma can be used to process municipal solid waste kind of thing, how they can, the carcinogenic or hazardous waste can be broken into their atoms so that they become benign, and overall process system how it looks. So I stop here. In the next class I will be explaining some more applications. I will be discussing some more applications of plasma, including non-thermal plasma, and I stop here. Meet you in the next class. Okay, thank you.